In this screencast, we are going to look at some of the characteristics that distinguish ionic and molecular bonds. Let's get started. The force that holds together an ionic compound is very strong, and it's an electrostatic attraction. Electrostatic means that there's a positive end and there's a negative end and there's attraction between those two ends. So that's what's holding together an ionic compound. Because of this, ionic compounds characteristically have very high melting points. They're hard, but they're brittle, which means they can crumble. They are not electrical conductors in the solid state because when they're solids, the ions don't move, and so they can't conduct electricity in that state. In contrast, the forces of attraction between molecules of a covalent compound are much weaker. Because of this, they melt at a lower temperature. So let's look at how you distinguish between the bonds. So there are two types of bonds, ionic and covalent, and there are two types of covalent bonds, polar covalent and nonpolar covalent. So this should say nonpolar, so make sure when you write it you add that extra N there. I missed that when I was creating this. So to determine whether you have an ionic bond, a polar covalent bond, or a nonpolar covalent bond, you want to look at the electronegativity values. These can be found in figure 20 and also figure 2 in the modern chemistry book, and the information is located at the top of the screen. So in general, if you're dealing with a polar covalent bond, the difference in the electronegativities between the elements will be between 0.3 and 1.7. If your difference in electronegativity is 0.3 or lower, then you're dealing with a nonpolar covalent bond. And if the difference in electronegativity is 1.7 or higher, then you're dealing with an ionic bond. So we can look at the electronegativity values and tell exactly what type of bond we have. The other thing we can do is look at the elements that make up the bond. An ionic bond is formed between a metal and a nonmetal. Covalent bonds are formed between two nonmetals. So if you have two nonmetals, you know it's a covalent bond, but you're not going to know if it's polar covalent or nonpolar covalent just by looking at the elements. So metal and a nonmetal is ionic, two nonmetals is covalent, and we also want to look at their electronegativities. So let's look at these examples. Sulfur has an electronegativity of 2.5, and hydrogen has an electronegativity of 2.1. So if we were looking at a sulfur and hydrogen bond, and we were going to compare the electronegativities, the 2.5 minus the 2.1 gives us a 0.4 difference. So that means that sulfur and hydrogen form a covalent bond. In comparison, if we combine sulfur with cesium, and we compare those electronegativities, we take our 2.5 for sulfur, subtract our 0.7 for cesium, and that gives us a difference of 1.8 in our electronegativities. So this is an ionic bond. And finally, if we combined chlorine with hydrogen, chlorine has an electronegativity of 3, and hydrogen has an electronegativity of 2.1. 3 minus 2.1 gives us a difference in electronegativity of 0.9. So this is a covalent bond, but even more specifically, it's going to be a polar covalent bond. So again, we can determine the type of bond that's formed by looking at the differences in the electronegativity or by looking at the elements that combine to form that compound. Anytime a metal is present in the compound, it's going to be ionic, and if it's two nonmetals, it's going to be covalent.